Section 419 is called compound generator. We'll look at the compound generator as this design that improves the voltage regulation over a separately excited and a self-excited connection scheme for the field type generators. It's a very simple solution and very easy to understand. So we'll look at the representation of the compound generator, and then we'll see what this really simple solution does in terms of improving the characteristics of the generator. So the compound generator was developed to prevent this terminal voltage of the DC generator from decreasing as you increase the load. So, you know, DC generators, like we mentioned before, they're not used as much as they were at one time, but you know, think about the problem that an increased load causing a drop in the terminal voltage. Think about the problems that could bring to us. He gives an example, say that a DC system on a ship, and it supplies both power to DC machinery and incandescent lamps. And say that the current delivered by the generator changes constantly due to varying loads, right? The load increases, the current increases, that terminal voltage would, decrease because of that. And so these current variations correspond to changes in the terminal voltage, and it could cause things like lights to flicker and so forth and so on. So a compound generator changes all that. A compound generator, is shown in this figure 425, it's similar to a shunt generator. And I think, let's start looking here at this slide. I think it's simpler to see here. So here's our armature, the E sub O right here. And so here's a situation, and I have a shunt field that is in parallel with the armature, but I'm also going to add something else here, a series field that is in series with all the current that flows through the load. These series coils are composed of a few turns of some very heavy wire that can carry all of the armature current. So it's a larger gauge wire. The total resistance of the series coils, because the wire is of a larger gauge, is therefore very small. Now, look, he's even tried to show us and represent this in the physical drawing, and see how these series coils creating the series field, they're shown in our drawing as a thicker gauge wire. And this is our shunt field here. And if you kind of follow this out a little bit, you could see how this shunt field is in parallel with this. You can see it here in the sort of pictorial of this thing, but it's much more obvious, and it's a lot easier to see, I think, with the schematic diagram there. Okay, so we'll call this the first video. We'll call this part 1. And what we did is we defined this compound generator, and we have shown the connection or schematic for that compound generator. And what we'll do in the next video is we'll discuss how this construction causes a completely different set of characteristics for us.